Hi everyone, in this video we're going to look at a few examples of global extrema, so let's do it. Let's look at part A. Identify each labeled point as an absolute maximum or minimum, a relative maximum or minimum, or neither. So we have this function, and we have 4 points, point A, B, C, and D, and we have to analyze each point. So let's take a look at point A. We can clearly see that it's not an absolute maximum or minimum because we see points that are higher and lower than A. So for example, B is higher and C is lower. So this is not an absolute max or min. And we also see that it's not a local min or a local max because we know that local minimums or maximums are at the bottom of a valley or at the top of a hill respectively. So A is going to be neither. Let's look at point B. This is a classic example of a local maximum. Alright, we see that it's right at the top of this little hill. Okay, so this is a local maximum. Let's look at point C. Point C is a classic example of a local minimum as well, because it's right at the bottom of this valley. But if we look closely at this function, we see that it's also an absolute minimum because it's the lowest point on this function. If we compare it to the rest of the points, we see that it's the one that is the lowest. Now finally, let's look at point D. Point D is an absolute maximum. We can clearly see that it's the highest point on this function. It's higher than any other point. Okay, so now let's look at part B of this example. Find the absolute maximum or minimum for f of x equals x squared minus 2x on the interval from x greater than or equal to -1 and less than or equal to 2. So we have to look at only this domain. Okay, the way to find the absolute maximums or minimums is to analyze the critical points and to determine if the critical point is a maximum or a minimum, and then compare them to the endpoints. Okay, the endpoints are going to be the only other points where we have absolute maximums or minimums. Okay, so if you look at, for example, the diagram on the right, we have a local max and a local min, but we also have to compare the endpoints. Okay, in the case of the minimum, C is lower than the two endpoints, so it's going to be a local minimum but also an absolute minimum. But if we look at point B is a local maximum, but when we compare the endpoints, we see that point D is actually higher. So point D is the absolute maximum. Okay, so the process is going to be something similar for part B. We have to find the local minimums and maximums using the critical points, and then compare them to the endpoints evaluated using the function. So let's look at the solution here. So we have the function f of x equals x squared minus 2x. And we can easily find the derivative using the power rule. In this case, we have that the derivative is equal to 2x minus 2. Okay, and to find the critical points, we can set this equal to 0 and then isolate x. Okay, doing a little algebra, we have that the solution is x equals 1. So our critical point is going to be 1. Notice that the derivative is defined for all of the domain, so this is actually going to be our only critical point. Okay, now if we wanted to determine if it was a maximum or a minimum, we could look at the second derivative. In this case, the second derivative is easy to see that it would be 2, positive 2. So that makes our function concave up, and that will make this critical point a minimum. Okay, but we don't know yet if it's the absolute minimum. We have to compare it to the endpoints. So our first endpoint is -1. When we plug in -1 for x in our function, when we evaluate f of -1, we're going to replace -1 for x, and we have a final answer of 3. Okay, so now we're going to replace the second endpoint, which is 2, So f of 2, again by replacing 2 in place of x, and when we evaluate we have a final answer of 0. Remember that we have to compare this to the critical points. Okay, so we have to evaluate our critical point as well. So our critical point is 1. We're going to replace our function x for 1. So f of 1, our final answer is going to be -1. Okay, now we can compare. We see that our critical point actually gives us the lowest value. So our critical point is not only a relative or a local minimum, it's actually also our absolute minimum, because we have that it's the lowest value when we compare it to the endpoints. Okay, and of course the highest value comes from our first endpoint, -1, because it gives us 3, which is the highest value there. So the absolute maximum of the function is 3, and that comes from our endpoint, and the absolute minimum is -1, which comes from our critical point. Okay, well, that's it for this video. Thank you for watching, and see you next time.